Hey, come in close. I have a secret to tell you. It's a secret that is common and everybody knows it, but nobody ever talks about it. And so it's something I need to talk about. You ready? Every whole number has a hidden decimal at the end. Okay, yes, it was a math secret. And yes, it's actually not really a secret at all. But still, nobody ever talks about this. And it's something that is really important because there is a decimal hidden at the end of every whole number. But we just don't put it there. So let's think of a whole number. What does Mrs. Bieber mean by this? So, a whole number like the number 6. Did you know there is actually a decimal point after the 6? We just don't write it there. It's that common that we just don't write that decimal point in. Let's do another one. How about 17? Guess what? There's a decimal at the end of that 17. Just nobody ever talks about it, and we don't write about it because it's so common. Did you know that? Let's look at why this is important. Everyone, this is a place value chart. Wave hi to the place value chart. And it includes our decimal point right here. Everything to the left of the decimal point is a whole number. Everything to the right of the decimal point is a decimal. So you can see in our place value chart that if I were to write a number in a whole number, look, there would be a decimal point right after it. We just usually don't write it. Why is Mrs. Bieber talking about this when we've been talking about exponential notation and expanded multiplication and powers of 10? Well, when we multiply a digit by a power of 10, it has everything to do with the place value and the decimal point. So let's look at this. How is the place value of a digit affected when you multiply or divide by a power of 10? Let's think of 5 times 1. What does 5 times 1 equal? Yes, 5. That one was very easy. Now think about it. There should be a decimal point after that 5. And there is, usually though, we just hide it. Let's look at how that decimal point changes if we multiply the 5 by 10. What's 5 times 10? It's 50. So now, how many digits are before the decimal point? How did the decimal point move? Let's look at another one. 5 times 100. 5 times 100 is 500. How did that decimal point move? Now we have 5 times 1,000. 5 times 1,000 is 5,000. You guessed it. How did that decimal point move? Well, if you said that it moved one place value to the right every time, you would be correct. 5 times 1 is 5. 5 times 10, move that decimal point once over, and you get 50. 5 times 100, move that decimal point twice over, and you would get 500. 5 times 1,000, move that decimal point 3 spaces, and you get 5,000. The number of decimal places that the decimal moves, or the number of place values that the decimal moves, is completely related to the number of zeros in the power of 10. It works the same with division, except for instead of the decimal point moving to the right, the decimal point is actually going to move to the left because the number is going to get smaller. So let's think about it this way. I start with 5. 5 divided by 10, if there's the decimal point here, I need to look. How many zeros are in 10? 1. So we are going to move that decimal point one place to the right, to the left. 5 divided by 10 is equal to 5/10. 5 divided by 100, how many zeros are in 100? 1, 2. So I am going to move that decimal place 2 places to the left. Now look, I have an empty loop right here. 0 makes a great placeholder. So I'm going to put a 0 here to fill that empty loop. And guess what? 5 divided by 100 is 5/100ths. Then I have 5 divided by 1,000. I have 3 zeros in 1,000, so I'm going to move my decimal point 3 places to the left. I have 3 loops because there are 3 zeros in 1,000. Remember, 0 makes a great placeholder, so my answer is actually going to be 5/1000ths. Let's try this a little more, but here is the rule. Remember, when you're multiplying by a power of 10, you move the decimal point 1 place value to the right. When you're dividing, you move the decimal point 1 place value to the left. Let's try this. I have 165 times 10 to the second power. So I am going to rewrite this so that I can have a little bit more space with the decimal point at the end of the whole number. If I think about 10 to the second power, how many zeros are in that standard form? It's actually like saying that I have 165 times 100. Sorry, that's a 0 there. Remember, 10 to the second equals 100. So if there are 2 zeros in this number when it's written in standard form, my decimal point is going to move over 2 spaces, 2 place values. So I'm going to have 1, 2. And I am going to use a 0 as a placeholder. Now if I rewrite that, then I will have 16500. And I will have 16,500 for my answer. It works the same way with division, except for you go to the left instead of the right. You need to make the number smaller instead of larger. So I have 165 with the decimal point after it, because that's the secret. And I'm dividing it by 10 squared. I'm dividing it by 100. Because remember, 10 squared written in standard form is 100. There are 2 zeros because it is 10 squared. So I am going to divide, which means move my decimal point to the left 2 spots. Now, there is no place value holder that I need to add. I don't need to put a 0 anywhere. I just need to make sure that I put my decimal point in the correct spot in my answer. So 165 divided by 10 squared, or 165 divided by 100, is going to be 1 with a decimal point 65, 1 and 65/100ths. Let's try this again, but we're going to start with a number that has the decimal point in the middle of it. I have 16 and 5/10. I'm going to take 16 and 5/10 and I'm going to multiply by 10 to the third power, which means I am going to take this decimal point and I am going to move it 3 spaces. So I will take and go 1, 2, 3. Now, one loop already has a 5 in it. I need for my other 2 loops to put place value zeros. So my decimal point will go at the end. So I know that I will have the answer of 16,500. What if I did 16 and 5/10 divided by 10 to the third? Remember, I need then 3 loops, the 3, this part tells me, to the left. So I need to go 1, 2, 3. And my decimal point will move over here. Now, I need a place value holder 0 to go there to fill the empty loop. So I am going to have the number 165 10,000ths with my decimal at the very beginning. Now is your turn to try a few of these. Okay, so looking at this one shows me with the loops already created, and it shows you how that decimal point can move based on the exponent of the power of 10. If I have 6/10 times 10 to the 6th, remember I'm multiplying, so my decimal point's going to move to the right. I move it to the right one place. So my answer is going to be 6. That decimal point moved to the end. If I have 6/10 times 10 to the 2nd, I need to move that decimal point 2 places. So I am going to have 60. 6/10 times 10 to the 3rd, I'm moving that decimal place 3 loops with 2 placeholder zeros, so I'm going to have the answer 600. What would be 6/10 times 10 to the 4th power? You solve that now. What if I'm dividing? I have 4,523 divided by 10. So I'm moving that imaginary decimal point 1 place value to the left. So my answer is going to be 452 and 3/10. If I'm dividing by 10 squared, my decimal point is going to move 2 places. So I'm going to have the answer 45 and 23 hundredths. If I divide by 10 to the 3rd, because it's 3 zeros, I'm moving 3 place value parts. So I have 4 and 523 thousandths. What would it be if I have 4,523 divided by 10 to the 4th? Answer that one now. So, for your follow-up activities, you are going to do Math Journal page 45. That will be a seesaw activity for you, along with Math Boxes 2.3. Mrs. Bieber is also going to assign High Number Toss. That is an everyday math game. Try to go on and play it. It hasn't been working very well, and we've been having a lot of technical difficulties. So if you go on and try, I'd like you to just put me a note that says, I tried, it didn't work. If it does work, great. Here are going to be your activities for Monday and Tuesday. If you and I were in person, I would be having you take out your assignment book, and I would be having you write down these assignments for Monday and Tuesday. You can see that they all deal with activities that we have been working on and learning about yesterday and today. For Monday, you will be doing HomeLinks 2.2. That is in your Everyday Math HomeLinks book that you should be keeping at home. It's the one with the 3 dots down the side. Go ahead and do that work in your Math HomeLinks book, and then take a picture with your iPad and put it in the seesaw activity. When you take a picture with the iPad, please make sure that you're holding the iPad directly over top of that page. That way, Mrs. Bieber can see your work. Then you'll be doing your number of the day. Hopefully, High Number Toss will have all of its kinks worked out by that point. And you will have an additional activity in Seesaw called Powers of 10 Equations. Remember, every single one of these activities has a Seesaw activity with it. So if you are on Seesaw and you are completing all of your activities on Seesaw, you will not miss anything. On Tuesday, you'll be doing HomeLinks 2.3. This time you will include the practice. Then you'll be doing the Powers of 10 choice board. Please remember, like the instructions say, to circle the choice that you are working on, so that way Mrs. Bieber knows what you are answering. You are also doing the Powers of 10 error analysis. Again, please read those instructions very thoroughly. They are the instructions that are on the instructions Mrs. Bieber writes on the outside of the activity. Then you are doing your quick check. That quick check is going to be graded. Hope you have a great rest of your day, and I can't wait to see you guys in person next week.